Okay, so first step, I think that you should make sure that you do is if you decide to implement this procedure next, just to remove the comment and 0 from this call table so that we can start calling this procedure officially without generating some kind of error message. So this is step number 1. And this probably is very similar to plus. So our binary minus could do exactly the same thing. I mean, we can probably just copy and paste this logic to replace the to-do comment with this implementation. And so remember, the task here is to grab this left operand and deduct the value of the right operand from it. So all of the previous work dispatching the call, interpreting all user input, encoding the values corresponding to these procedures, all of this hard work just resulted in this simple task that now we can start handling these calls just by implementing the correct arithmetic. So of course we're going to replace addition with subtraction, and here probably update the comment that this is subtraction, the right hand side operand from the left operand. The EAX should be indicating success, and of course what could be improved in overall in this entire idea of using assembly level for doing these actual computations, like this binary minus that we just brought in and just implemented its logic in a matter of seconds, really, that we could actually check for overflow, right? We can check perhaps we can decide that we should use signed arithmetic and allow user to use both positive and negative numbers. Right here, for instance, we can now say plus minus 10, right? So here oh, actually, no, it doesn't. It probably interprets the minus as a binary minus. So I'm sorry, no, that's not working right now. It will start working as we start implementing binary minus. But regardless, it's not the idea. The idea is that if we interpret proper results and try to interpret the overflow, that we could possibly add additional error codes to our procedures. I would definitely take this for an extra credit. I think there is plenty of work left to do without this, but it's just something to think about, the possible reports of an overflow. So this is an example of binary minus. If you think about the modulo operator, we can very easily compare it to the binary divide, right? So if we take a look at the binary divide, remember that the same exact instruction here generates both the quotient and the remainder. So it's up to you what you want to store, and you can grab the remainder. So it should be pretty trivial for you to follow the idea that it's the same exact implementation. We could even possibly make the same procedure handle both, but I would not recommend it. I would just copy and paste the implementation of this binary divide and duplicate its logic here, but really just use the remainder instead of EAX to get the result back to the calling procedure. So as an example, I would like just to maybe try assignment. Okay, that should be pretty trivial. We really don't even have to do any work. We just need to be able to grab the left-hand side operand, the right-hand side operand, and store it as a left-hand side operand. All right, so let's do this. Okay,
for an example here, we can just do this binary assignment, let's just take a look at what we did in subtraction. So subtraction or binary minus. So we need to move the right hand side operand into left hand side operand. So we can do it like this, and let's just copy this over again one more time and quickly make changes. So here is the assignment, which is the last procedure here. So I'm just going to replace this implementation like this, and so we take the idea is to take the right operand and assign it to the left hand side operand. So we load the right operand into EAX, and we can just simply move this EAX into the running total. This is the global variable that represents the running total. We just set EAX equals 0 to indicate success of this, and it's pretty straightforward and very, very simple. So with this in mind, so just important that remember I had to remove these zeros for binary minus and binary assign before I decided to write any code for these. So let's make sure that we test this now. Okay, and let's test the results. Hopefully we can get some positive results from what we did. And I'm just going to build this. Hopefully there are no any kind of bad errors. It does report essentially that these procedures are never invoked, but they will be invoked when we complete the implementation. So these are just warnings displayed here. Nevertheless, let's just give it a try. I'm just going to say just debug, start without debugging, or press Ctrl F5 to run this, and I'm curious to check our new functionality such as assignment. So equals 100 now works. So used to generate error codes. Now it works just fine because we added it to our call table. So the new one is also minus, right? So minus 200. So this is quite nice, and now the minus is the default operation. So again, we can just say plus 50, and we get minus 50 as a running total. Okay, and the division also works. So the division works, and addition, subtraction, assignment now works. So what's left is really just multiply. I think multiply is the biggest challenge here because it involves just more effort to write code. So I'll just leave it to you as an exercise.